Selamat malam Bapak Ibu semuanya. Ini beberapa teman, ada Pak Utomo, Pak Joko, Bu Ari, Pak Kiswanta, Pak Woto, banyak ini.
Selamat malam Pak.
Selamat malam.
Angling ya Pak Jarot.
Kenapa?
6 ya.
Loh.
Tambah 6.
Iya, memang harus tambah 6 kan? Iya, gitu ceritanya kan. Kebanyakan WFH kan?
Apa ya?
Tidur katanya.
Iya. Apa?
Alhamdulillah.
Ya, Pak. Amin.
Kita mulai 7:30 ya. Saya masih menunggu Pak Ketua ini, Pak Susilo Widodo. Belum hadir ya Pak Muji ya?
Sepertinya belum, Pak.
Oh, belum. Ya, moga-moga on time beliau.
Sebentar saya ingatkan beliau dulu, Pak.
Ya, kalau enggak Pak Sekjen yang sebagai pengganti Pak Ketua untuk pidato.
Sekalian diwakili Dewan Pendiri, Pak. Bentar izin, Pak, izin.
Monggo. Udah ada itu. Pak Sus.
Alhamdulillah udah Pak, udah masuk.
Oh iya. Kalau enggak itu Pak Muji saya minta nanti speech loh.
Ya, memang posisi gitu.
Ini Pak Dekan FT Untan sudah hadir. Waalaikumsalam Pak Rustam.
Waalaikumsalam Pak Rustam.
Many bebas. Join. As almost 100 participants.
Pendaftarnya luar biasa, 450 kali ini. Sibuk sekali Pak Dekan ya, Pak Rustam aja.
Ya, biasa, Prof.
Pembicaranya Pak Artem Larionov sudah hadir, jadi tadi sempat bicara. Ini juga dari IEE Pak Frederick Ritzma juga hadir. Rekan-rekan dari Rusia juga beberapa sudah hadir. Ya, nanti saya mungkin akan membuka sedikit pakai bahasa Indonesia. Setelah itu kita pakai bahasa Inggris. Nanti presentasi pakai bahasa Inggris, mungkin pertanyaan dari beberapa penanggap dalam bahasa Inggris. Wah, udah ada Pak Suryantoro itu.
Assalamualaikum Pak Jarot dan rekan-rekan semua. Salam HIMNI, salam nuklir.
Waalaikumsalam Pak Suryantoro.
Waalaikumsalam.
Wah, Pak Suryantoro tuh hebat banget tuh, pakai apa itu kepalanya?
Mau tak ganti nih. Bagus. Ya.
Katanya bar sholat tuh yang bisa nge-batsi.
Oh iya.
Masih 2 menit lagi. we are still waiting for 2 minutes, Mr. Larionov.
Okay.
Yeah. Ini webinar berikutnya limbah radioaktif, Pak Surya. Kita cari waktu.
Setuju Pak Jarod untuk waste management.
Sip.
Ya.
Kemarin udah ngomong sama Pak Kapusnya.
Oke, ya. Makasih.
Mosok aku di PTLR nggak ngadain untuk limbah radioaktif.
Nah, iya, makanya itu. Harusnya komplit, bahan bakar sudah. Ya, Pak Agus kemarin.
Ya.
PLTN, nah mungkin perlu semuanya itu mungkin untuk sharing knowledge kan nggak apa-apa. Ini waste juga harus yang back end-nya juga komplit kan gitu.
Ya.
Makasih Pak Jarod.
Yuk sami-sami nanti kita cari waktu.
Ya,
kita mulai ya. Saya akan memute-kan semuanya. Jadi nanti hanya beberapa yang bisa untuk kita minta untuk membuka mikrofon. Selamat malam Bapak Ibu sekalian, bahwa kita akan memulai webinar kali ini terkait SMR teknologi. Ini seri baru terkait small modular reactor. Jadi ini tindak lanjut dari tanggal 30 Juli yang lalu kita mengadakan webinar. Mungkin rekan-rekan ada yang ingat, ada yang ikut. Waktu itu kita menggunakan judul Energy Outlook dan Potensi Pemanfaatan SMR. Waktu itu ada Pak Hadid Subki dari IAEA menjelaskan terkait ada 3 jenis teknologi yang sudah dan dalam waktu dekat bisa dimanfaatkan atau dioperasikan, yaitu pertama KLT40S, kemudian yang sudah terkoneksi ke grid, kemudian juga ada HTRBM Tiongkok yang tahun depan mau beroperasi, dan ada KRM 25. Nah, kali ini sebagai pembuka atau nomor 1 dari SMR teknologi untuk webinar kali ini adalah KLT40S. Jadi nanti di akhir acara tidak saya simpulkan apapun, silahkan untuk bisa menyimpulkan sendiri kaitan dengan PLTN Terapung satu-satunya di dunia ini. Nah, nanti selama seminar kami akan menggunakan bahasa Inggris. Jadi ini bagian dari kita share pengetahuan bagi khalayak, bagi semuanya yang antusias terhadap nuklir. Mungkin bagi rekan-rekan Batan sudah cukup mengenal apa itu PLTN Terapung, tapi mungkin banyak yang tidak mengenal. Ini tujuannya adalah kita mendapatkan pengalaman pengetahuan dari pihak yang memiliki teknologi. Terima kasih terhadap Rosatom yang bersedia untuk berbicara kali ini terkait PLTN Terapung. Saya akan memulai dalam bahasa Inggris. Good evening, ladies and gentlemen, dear colleagues in Indonesia, and good afternoon in Moscow and in Russia. This is a special event for us to hold a webinar, new webinar, because we have already 13 webinars. The Indonesian Nuclear Society has already conducted the 13 webinars, not only talking or discuss about nuclear energy, but also the nuclear in medicine, the use of radioisotope and radiation in agriculture. So, and following our July 30 webinars, we invite speakers from the IAEA, from the International Atomic Energy Agency. At that time, the speakers from the agency explained that there are 3 SMR technology that already deployed or in the near future will be in operation. The first one, last year, is already connected to the grid, is the floating power plant, nuclear power plant from Russia, the KLT40S. And then after that, other SMRs. Maybe some of people in Batan, well, they are familiar with the SMRs, but maybe the audience mostly not coming from Batan. I'm very happy today because the research, there are 450% registered in this webinar. They will watch through YouTube, or they are participate in this using this Zoom platform. We have a good communication with Rosatom, and today there will be a special speakers. Mr. Artem Loyanov will explain about what is the floating nuclear power plant, and as usual, I'm going to invite the chairman of Indonesian Nuclear Society, Dr. Susilo Widodo, to give the opening speech. Please, Pak Susilo.
Okay, thanks. Okay, thank you, Pak Jarod, for your for my time to deliver a very short speech, and I'm sorry my English is very limited vocabulary, and actually it's not good spelling English because I came from Yogyakarta, so we call Janglish, Javanese English.
I'm from Yogyakarta also.
Yeah. And good evening for all participants from Indonesia, and good afternoon our distinguished speaker and participant from Russia. When I Dubraye Ultra, this is the greeting what I can, the only greeting I can say in Russian, Dubraye Ultra.
This is good morning in English. we have good evening. Good evening. Dobry вечер. Dobry вечер.
Yeah. Sorry, that's the only greeting I can spell in Russia. Okay.
You have good pronunciation in Russian. Good pronunciation.
Thank you very much. Okay. This evening, I think all of us have opportunity want to hear from the first hand of information about the academic Lomonosov. It is spelling good, Lomonosov.
Yes, that's correct. That's correct.
Floating nuclear power plants, the first in the world nuclear power plant in Russia. Congratulations, because currently, if we heard number 19, our imagination is coronavirus. But for you, for Rosatom, it should be the good number. For number 19, it should be good number, because we know that the academic Lomonosov has started operation on 19 December 2019 in Chukotka. This is what I hear. Congratulations. And because of this, of course, our community, HIMNI, Indonesian Nuclear Society, would like to know the ins and outs of the Russian floating nuclear power plant, and of course, then the potential to be operated in archipelagic countries like Indonesia. Okay, this all what would I say. We want to hear a little bit detail about how the safety of the plant and many other things. That's hopefully our distinguished speaker, Dr. Artem Larionov, would deliver for us. Thank you, and have a nice presentation.
Yeah,
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you
Thank you,
very
Pak
much,
Jarod. Yeah.
Pak Susilo Widodo, the chairman of Indonesian Nuclear Society. Before Mr. Artem Lorionov give the speech, I will give you a overview of the Rosatom. Maybe later on, Rosatom is very big. Later on, Mr. Lorionov will explain also. It's a big company. I think it's a state-owned company. They are very active right now, the main player on the nuclear energy business in the world. As we know, they are constructing the nuclear power plant in Bangladesh, in Turkey, Belarus, Hungary, Finland, and Egypt. Well, we cannot avoid the Russian as the main player of the nuclear energy business. And I would like to give you the CV of Mr. Artem Lorionov. He is a marketing expert at Rosatom Overseas. Rosatom Overseas is a part of Rosatom. Rosatom Overseas is responsible for bringing the exclusive Rosatom integrated offer for large and small scale nuclear power plants to the global market. Mr. Larionov is particularly in charge of promotion of SMRs and floating nuclear power plants on foreign markets. He is also a member of Rosatom Overseas Analytics team, which is primarily involved in global energy landscape monitoring, assessment, and strategy elaboration. I think he is the proper person to explain. Well, I expect it's not only in the technical terms, words. I has already said to him, please use the general language that everybody here, the audience can understand what is the floating nuclear power plant. Please, Mr. Larionov.
Thank you. Dear colleagues from Indonesian Nuclear Society, dear attendees of this webinar. So it's a great pleasure for me to attend this meeting. And first of all, I would like to thank the organizers, colleagues from Indonesian Nuclear Society for kindly inviting Rosatom to this event. In my presentation, I will speak about current activities of Rosatom in terms of SMR development, about the world's only floating nuclear power plant, and the SMR solutions that Rosatom is ready to offer to its potential customers. So can you see the presentation?
Yeah, wait, okay.
So, okay, next slide, please.
Wait.
Oh, that's great. So let me start with a brief overview of Rosatom, and I would like to add some words to the colleagues. Rosatom is one of the leading energy and technology companies on a global scale. It is a unique virtually integrated company that comprises of more than 300 subsidiaries. And I'm proud to say that this year we celebrate the 75th anniversary of Russian nuclear industry. So you can see some highlights about our company at the slide. I'm proud to say that we are number one in the world by NPP units in international backlog. Currently, we have 36 units in our overseas portfolio, and we are doing business in more than 50 countries around the globe. So last year, we set the record of power generation. More than 209 billion kilowatt hour of electricity was generated by our NPPs in Russia, thus making us the leading generating company in our country. So next slide, please. Rosatom is the only company in the world to offer integrated clean energy solutions across the nuclear supply chain and beyond, including design, construction, and operation of nuclear power plants, uranium mining and conversion, enrichment, supply of nuclear fuel, decommissioning, and safe nuclear waste disposal. Next slide, please. So why are SMRs so important to us? From the one hand, we see that the global energy market has changed dramatically over the recent years. Smart grids are developing, energy systems decentralization is required, and renewable energy sources now make a great impact. We see a trend for decarbonization globally, and we see a transition to projects with low capital intensity. So on the other hand, we as Rosatom have great expertise in large-scale NPP construction around the globe. More than 100 Russian-designed NPPs, NPP units have been constructed globally. What is more, we have wide experience in small reactor technology development for icebreaker fleet. So thus, we develop our new products, particularly SMRs, as an effective example of small capacity energy solution to correspond to these new market requirements and needs. Next slide, please. So OKBM Africantov is a subsidiary of Rosatom and is a chief designer of small reactors for marine applications. Since 1954, OKBM has designed and manufactured over 20 small reactors for civil marine applications. And we have accumulated great expertise of operation of small reactors for icebreaker fleet over 400 reactor years. Next slide, please. We now have 4 nuclear icebreakers and 1 nuclear light highboard ship carrier in operation. Well, now Rosatom is renewing its icebreaker fleet, and we are developing 2 classes that would be more powerful than the existing ones. I'm proud to say that these classes will be based on new generation of SMRs of Ritom series, and I'm proud to say that 6 Ritom series reactors have been manufactured and installed on universal icebreakers, Arctica, Sibir, and Ural. And these icebreakers will have variable draught and will be able to navigate both shallow rivers and deep seas in the north. And in November 2019, 2 Ritom series SMRs attained criticality. So we can say that these reactors are fully referenced. And after entering service this year, this icebreaker will become the most powerful icebreaker in the world, being able to break through ice up to 3 meters. And icebreakers Sibir and Ural with Ritom series SMRs as well, to enter operation in 2021 and 2022 respectively. 2 more icebreakers of this kind have been contracted. Next slide, please. So Russia pays great attention to the development of the Northern Sea route, a shorter connection between Europe and Asia and the Arctic region in general. So the amount of time each year that this route is clear of ice and can be passed by ships is increasing due to the global warming. And in March 2020, Russian president signed a strategy document that outlines Russia's intention in the Arctic region for the next 15 years. It includes measurements to improve the socio-economic situation in the communities, as well as the further promotion of the development of the Northern Sea route. It is our national priority to reach at least 80 million tons of annual goods traffic already by 2024 and 120 million tons by 2030. So we plan to increase it in 9 times. So to reach this target, Rosatom is already developing the new generation of icebreakers. They are called Leader with Ritom 400 reactors that will ensure year-round navigation by 2030. Next slide, please. So based on that vast experience of design, manufacturing, and operation of small reactors for icebreaker fleet, we developed the world's only floating nuclear power plant, Academic Lomonosov, named after prominent Russian scientist. The plant will enable reliable safe and affordable energy supply to and ensure sustainable development of key industries of Chukotka destination region. So it will replace PVEC aging Bilibino nuclear power plant and Chaumsk coal-fired power plant, saving about 50,000 tons of CO2 emissions per year compared to the current levels. It is equipped with two KLT40S pressurized water reactors that can generate up to 77 megawatt of electricity or up to 300 megawatt of thermal energy. This may be quite enough to provide a large industrial facility or a small town with a population of more than 50,000 people. Well, these reactors are quite similar to those used on icebreakers, so they are tested. This is a tested solution and designed by Russian nuclear scientists and naval architects. Well, the vessel. So I don't see the slide. Okay, this is it. So the vessel itself is 140 meters long and 30 meters wide and has a displacement of 21,000 tons. One of the biggest challenges for our Russian scientists was the need to maximize the period of permanent work on site without interruptions for fuel line loading and maintenance. So the achievement of FNPP Academic Lomonosov is its own fuel storage on board and refueling system, which allows, in fact, to reload itself, let's say. Due to this, the fuel cycle is extended to 3 years, and the maintenance period is once in a 12-year time, 10 to 12-year time. So after 10 or 12-year period, it has to be transported to the shipyard, and it should be maintained. This procedure lasts for about 1 year. So the total lifetime of the FNPP is 40 years with possible extension. Next slide, please. So now a few words about the status of the project. In April 2019, comprehensive testing of the reactors were finished. In June 2019, the operator of FNPP Rosenergatom, this is a subsidiary of Rosatom that operates all the nuclear power plants in Russia. So it was granted an operation license by Rostechnadzor, our regulator. In September 2019, the FNPP was successfully transported from Murmansk to PVEC, and it covered more than 4,700 kilometers. So in December 2019, the FNPP was connected to the grid and started supplying electricity to the grid. And in January 2020, it delivered the first 10 million kilowatt hour of electricity to the Chukotka grid. And finally, in May 2020, it was fully commissioned and started supplying heat to PVEC city. Next slide, please. So basically, the FNPP consists of floating power unit itself, the vessel, special pier, and the coastal sites of the FNPP. Let me start with the coastal site. It consists of a closed switchgear that provides distribution and transmission of energy to consumers, electrical substation, heat supply station intended for the preparation and distribution of district heating water to the consumers, waste treatment facilities, and utility networks. The coastal site is equipped with a checkpoint with an access to FNPP territory, and there are video surveillance systems and alarms, as well as some emergency communication channels. The complex of hydraulic structures includes a special pier with devices for unfastening and the underwater pit that creates necessary conditions for the operation of the cooling systems. The pier protects the floating power unit from the ice, drift, and waves. Dams and breakwaters have been installed and it makes colliding with icebergs practically impossible. and coastal infrastructure prevents any possible impact either against the shore or the seafloor. The FNPP is located in a bay that ensures additional protection. Next slide, please. The floating power unit itself is a non-self-propelled barge, and it has to be towed to the site of operation. It is 144 meters long, 30 meters wide, and has a displacement of 21,000 tons. The barge is divided into three main parts. The central part that consists of, well, this is a reactor compartment, and it houses two KLT-40S reactors, spent nuclear fuel, and solid radioactive waste storage and handling equipment. In above, there are two steam turbines that process thermal energy into electrical power, and in the aft part, respectively, control systems and compartment unit, so and residential unit. Next slide, please. So the safety issues were put in absolute priority for us when designing the floating power plant. All Russian and international safety standards were observed when designing the academic Lomonosov of FNPP. The stress test conducted after the Fukushima accident confirmed the high resistance of the FNPP to severe accidents, including tsunamis, wind loads, and other hazards. The safety is ensured by a combination of active and passive systems, inherent safety features, and defense in depth principle. So there are 5 safety barriers that include fuel pellet, fuel cladding, primary circuits, a reactor containment, and containment room that is a system of cabins with an individual ventilation. The floating power plant has multi-level protection systems from external effects, including a double hull structure. And the security system excludes any possibility of terrorist attack or sabotage, either from the sea or from the ground. Next slide, please. The FNPP staff includes operating personnel and support staff. Overall, there are about 300 people. Operating personnel include 2 rotation shifts that swap every 1 or 1.5 months. And support staff consists of physical security personnel, firefighters, and administrative personnel. So Rosatom provide comfortable working conditions for FNPP personnel. For instance, living and meal expenses, as well as transport costs, are covered by Rosatom. 42 years is the average age of FNPP staff. Next slide, please. Rosatom is now ready to offer its potential customers SMR solutions that based on state-of-the-art Rhythm series SMRs, and they incorporate all the best features from their predecessors, KLT-40 ship reactors. Well, our Rhythm series SMR is based on time-proven pressurized water reactor technology and 400 reactor years of experience in operation of small reactors. The technology has proven its efficiency and ultimate safety throughout all stages of the life cycle. Innovative features like integral configuration has made it possible to reduce the dimensions of the reactor by 45%, the mass by 45% compared to KLT-40S reactor. And such design almost eliminates the classic large-scale loss of coolant accident. So 6 Rhythm series SMRs have been already manufactured, and 2 of them attained criticality in 2019. So we can say that Rhythm series SMRs are tested and reference solution. Next slide, please. So we are now developing the family of Rhythm SMRs, and our reactors are versatile and can be considered for nuclear icebreakers, land-based small NPPs, floating nuclear power plants, and you can see key parameters of Rhythm series SMR family on the slide. And further, I'm going to tell you more details about floating, about the second generation of our floating nuclear power plants and land-based SMR NPP. Next slide, please. So there are two options of small NPPs available, floating or land-based. They both are based on Rhythm series SMR. Next slide, please. FNPPs can be considered for a wide range of potential sites, including islands, archipelagos, offshore facilities, various mining and mineral processing facilities, both in the north and in the south. They could bridge transition times in regions that are undergoing structural changes, and these power plants could cover short-term energy requirements, for example, in large construction projects or drilling, offshore drilling. So multi-purpose application is possible. FNPP can provide electricity, heat, or desalinated water. This is a perfect solution for offshore and offshore facilities and wide range of potential sites as well. Next slide, please. So following the success of FNPP Academic Lomonosov, now we are developing an optimized version of the floating nuclear power plant. They are based on Rhythm 200M reactors, each of 50 megawatt. Compared with Academic Lomonosov, it will be more compact, more powerful, and more efficient. The electrical capacity will be increased from 77 megawatt to 100 megawatt, and fuel cycle from 3 years to 10 years, and the design life from 40 years to 60 years, with possible future extension. The maintenance period is the same as the fuel cycle, 10 years. So once in a 10-year time, there's a maintenance period and the fuel unloading as well. We plan to complete the concept design stage by the end of this year, and first of a kind of this energy solution is planned for 2027 or 2028. Next slide, please. FNPPs combine all the traditional advantages of nuclear power within its like continuous baseload energy supply, effective cost management, zero CO2 emissions, and multi-purpose application with something to offer on top of that. I'm speaking about a short period of construction works on site, no decommissioning on site, a long fuel campaign up to 10 years, and flexible lifetime period. What makes FNPPs unique is that they are built from start to finish in shipyards using the same expert construction technology as on nuclear icebreakers and Navy ships. There can be mass production of FNPPs, and therefore more efficient construction can be achieved than is currently possible with conventional large-scale nuclear power plants. In addition to cost savings resulting from the assembly line efficiencies of a shipyard, the FNPPs are very, very flexible and can be transported to another site. Next slide, please. Experience of Academic Lomonosov, as well as all Russian and international safety standards were considered when designing the FNPP. So the safety is ensured by a combination of safety of active and passive systems, inheritance safety features, and defense in death principle. These systems eliminate as many potential risks as possible, reduce the likelihood of accidents, and ensure that if an accident does occur, the consequences are minimal. The safety of the FNPP against external effects is provided by specific conditions of the site, and the choice of the potential site is very important to protect natural, to ensure natural protection of the FNPP. Then hydraulic structures, including a special pier and other features, and of course the design of the vessel and the reactor. Next slide, please. So now let me give you more details about our land-based solution. Next slide, please. So we are developing the land-based SMR and PP as well. It is equipped with RITM 200N reactors with an installed capacity of 106 megawatt. It has a design lifetime of 60 years and refueling cycle is up to 6 years. So the capacity factor will exceed 90% during the whole the 60-year design lifetime, making it a really reliable electric generation system. Speaking about the construction time, we plan to reach about 4 years for first of a kind, and we plan to decrease it to 3 years for next generation. So RITM series reactors can be used for multi-purpose applications, including electric power generation, water desalination, district heating, and due to its relatively small installed capacity and maneuverability characteristics, Rosatom NPP has a better compatibility with electrical grid infrastructure. Next slide, please. So scalable modular design is what makes Rosatom SMR a perfect fit for local energy needs. A capacity of the FNPP can be extended, meeting the growing energy demand. Construction of auxiliary areas construction of additional areas with the reactor and turbine buildings allows increasing power generation incrementally by step of 106 megawatt, while the auxiliary buildings area stays in shared use for all nuclear units. And obviously, we highly recommend our potential customers first to carefully study future electricity demand and choose the site that is ready to accommodate the projected MPP's capacity. Next slide, please. Except for civil construction, the whole of the Russian SMR NPP is intended to be modular, making it small, scalable, and factory built. The total weight of assembled RITM SMR is 244 tons. The heaviest component is the reactor vessel with the weight of 146 tons, and the dimensions of 4 meters per 3 meters and 7 meters. The reactor vessel is transported separately in a specially manufactured carriage for railway transportation, and road transportation is also possible with the use of heavy-duty transport vehicle. So other equipment will have modular design and fit for transportation by usual means of transport. So at the slide, you can see a real transportation of RITM series pressure vessel for nuclear icebreaker by railway. Next slide, please. So our flagship SMR incorporates all the safety features of the most advanced 3+ generation nuclear power plants. The high safety level of RITM series reactor is achieved both by inheritance safety features, combination of passive and active systems, and set of physical barriers, and of course Rosatom beyond design based accident management system. The combination of passive and active systems allows for a high level of control over the course of wide range of possible accidents than is possible within using only one type of system. In case of loss of coolant accident in combination with total station blackout, our NPP wouldn't need the intervention of the operator for 72 hours. And in case of only blackout accident or loss of coolant accident, the unlimited period is provided till the automatic core cooling. So our SMR NPP is resilient to various natural events. Special notice is taken to the protection against earthquakes. Design of the station allows to withstand peak acceleration of up to 0.3 G. However, our Rhythm series SMR taking into account its marina region is able to withstand up to 3 G. So it's possible for us to adapt the design of the nuclear power plant for stricter requirements. The design of FNPP takes into account the maximum potential external impacts, including large commercial aircraft crash, and we consider 20-ton aircraft crash as a design-based accident, and the large commercial aircraft with all related damage effects as a beyond design-based accident without large early release. So winds and tornadoes, according to F5 Fujita scale, including impacts of flying objects are also considered in the design. Next slide, please. So now a few words about SMR NPP first of a kind project in Russia. We have now started the implementation of this project, and we are considering several sites for the first land-based SMR NPP in Russia. The sites are very different. That shows that the project can address wide range of customer demands. The main target for this year is to determine which could be the best sites for our NPP, and we plan to get the site license by 2023, the construction license by 2024, and during that year we are going to start the construction of the plant, and by 2027 we plan to commission it. So I would like to quote the Director General of Rosatom. He said that an important aspect of our foreign practices is that Rosatom always follow the principle that firstly we build in our own country, and only after that we offer reference technology to the market. So we in Rosatom follow the policy to offer only reference solution to our customers. Taking into account the projected development scheme, it's possible we can say that Rosatom land-based SMR NPP can be deployed overseas, starting from 2028 and beyond as nth of a kind already. Next slide, please. So I must say that Southeast Asia is an increasingly important region for Rosatom, and we put great emphasis on Rosatom business development on the continent. And Indonesia is one of the Rosatom's important business partners in Southeast Asia, and we are ready to provide all the required support to our Indonesian partners in projects in peaceful use of nuclear energy in your country. And since being on the same page with our customers, and it has always been one of the key priorities of Rosatom, we're engaged in dialogue with the Ministry of Energy and Mineral Resources, Ministry of Research and Technology, Bataan and PT-PLN, for nuclear power projects promotion, and well, we carefully follow the Indonesian decision in the development of nuclear energy program. Next slide, please. We offer great opportunities for further cooperation to our partners within FNPP development. It can be industrial support, political support, or financial support as well. And I would like to mention that in December 2019, delegation of our experts visited Indonesia in order to discuss the prospects of partnership between our countries on nuclear projects implementation in Indonesia. And Indonesian energy sector stakeholders expressed positive attitude toward nuclear project development. So I hope for further development of our mutual cooperation between our countries. Thank you.
Thank you, Artem. Well, it's very interesting, and maybe so many persons will ask you about the possibility to build the floating or the land-based SMRs that you have already explained. And I will invite 4 persons first to give comment and or maybe questions to you. And I hope this 4 person will, representative of the audience or the participant that have various background. First, I would like to invite Dr. Kurtubi to give comment. He is the former parliament member, and he is also the energy expert, and he is pro-nuclear activist also. Please, Pak Kurtubi. Why I cannot unmute Pak Kurtubi?
Hello?
Okay.
Okay.
Please, Pak Kurtubi.
Yeah, first of all, I would like to say thank you for the very informative presentation from Rosatom tonight, especially about the SMR and floating nuclear power plant. Now, as we know, straight to the point, there are 2 main factors that are always used by the government of Indonesia in determining electricity policy in Indonesia, whether or not nuclear power plant will be used in Indonesia. Those factors are, first one, cost factor, and the second one is safety factor. We have heard from the Rosatom that SMR is very safe and very efficient. We hope that SMR from Rosatom can meet the qualification of the government of Indonesia in selecting nuclear power plant option in the future. Because of that, I would like to hear from the speaker. Could you explain? You have explained a lot about safety. It's very good, SMR. But how about the cost of SMR using in floating power plant, which is very have a big opportunity to be used in Indonesia, because we are here in Indonesia, we have a 1,000 small island that will meet they can meet their energy demand by SMR type of nuclear power plant. Yeah. Could you tell us about the cost that Rosatom can explain about floating nuclear power plant using SMR type of technology. The reason I am asking about cost is I explained before, because the government always use the cost factor in determining whether or not NPP can be built in Indonesia.
And also the electricity price.
Yes. I'm very, very optimistic that one day this big country will have to build a nuclear power plant, whether floating or inland. Okay, I'm very sure. And Rosatom is one of the suppliers that can be considered seriously to be invited in Indonesia. Yeah, that's a very, very important one. We have to know a little bit explanation about the cost of energy per kilowatt hour produced by floating nuclear power plant. Maybe not so very, very precise one, just a big rough future about the cost per kilowatt hour energy produced by floating nuclear power plant. That's my question. Thank you.
Thank you, Pak Kurtubi. Please, Artem, could you please directly answer that?
Thank you, Dr. Kurtubi, for your questions, for the question about safety and costs. Well, speaking about the costs, it's very important to understand that FNPP Academic Lomonosov is the world's first floating nuclear power plant in the world. And the deployment of first-of-a-kind projects of any technology is always more expensive than the next deployment. For example, first-of-a-kind projects include the expenditures for the technology development that significantly affect its costs. So the cost of the optimized version of the floating NPP will be considerably lower due to another type of the reactor, improved layout design, the learning curve, and other factors. And actually, it will be very unfair to tell you the exact figure of the electricity price per kilowatt hour or the other price parameters, as the particular costs of SMR and PP, both land-based and floating, can be they should be determined precisely and may vary greatly depending on site parameters, regulatory requirements, business model, and many other factors. So it is necessary to carry out the pre-feasibility study to determine even the range of the price that should be implemented, that would be implemented for the exact project. The target price for the serial version of FNPPs installed with the Rhythm Series SMR I aim towards successfully competing with both fossil fuels and renewables, as well as the possibility to enter the national grid through long-distance power lines. Well, speaking about the safety of the FNPP, the safety is provided by the design of the vessel and the design of the reactor that is based on great Rosatom experience in operation of small reactors for nuclear icebreaker fleet. And you know that the peak acceleration and for nuclear icebreakers are considerably higher than for ground SMRs and for nuclear power plants. And our reactor can withstand peak acceleration of up to 3G. So one more important thing that I would like to say, that the safety is provided by special onshore infrastructure, including the breakwaters and the special pier. The situation with reactor meltdown is excluded thanks to the vessel design, reactor configuration, and special hydraulic structures. So I guess I answered your question. Thank you.
Well, thank you, Artem. The second person to give comment, I would like to invite Dr. Rustamaji. Dr. Rustamaji, he is the Dean of Faculty of Engineering in Tanjung Pura University, West Kalimantan. I think right now West Kalimantan is very popular among us because they are intent to, well, they are interested on the NPP. Please, Pak Rustamaji.
Thank you very much, Professor Jarod, and very good evening for everybody, and very good afternoon or Ochen Dobry Den for Mr. Artem Larionov in Moscow. It is very interesting for me, maybe for us, since many people in the world thought that only one floating NPP in the world, and it is from Russia. And actually, for the first, I would like to get information about the safety, but in the present that has been presented by the Mr. Atom, I already get the information about the safety, and mainly for the response against extreme weather problems such as storms, tidal waves, even tsunami due to earthquakes. But I have still a question due to FNPP Russia. For the common NPP usually built on the certain area with certain security and protections. Could you please share us describing about the security and protection that applied on FNPP SMR, mainly due to the man-made disaster, not nature disaster? How it could be protected, how it could be protected, the FNPP. The second one, how it is similar with the Dr. Kubi questions, how does the cost of operations and maintenance of the Russia FNPP relatively compared to the common NPP for the similar capacity? Is it more expensive or what? It is important also for us. And the last question is, what's your opinion when FNPP would be operated in archipelago island like Indonesia? I think that's all for the first, Professor Jarod.
Okay.
And thank you.
Yeah, thank you. Please, Artem, directly you can respond to questions.
Okay, thank you, Dr. Rustamaji, for your question. And speaking about the security issues, it's they vary from country to country and should meet the specific country requirements. So in Russia, we have special military services that provided for FNPP Academic Lomonosov, and they provide security of the station either from the seashore and from the ground. So you see, it should be exact case for a specific country. Speaking about possible deployment of FNPP in Indonesia, we in Rosatom carried out some high-level analysis of SMR deployment in Indonesia, and we think that Kalimantan is can be one of the potential sites for the deployment. Speaking about this region, fossil fuel has 100% share in the energy mix, and coal reaches about 50%. So from our opinion, diversification of the energy mix is required. We do convinced that the implementation of SMR project in the region will support the development of strategic mining industries. And we know that about 2 gigawatts of electricity is required in the next 6 years. And the West Kalimantan province suffers shortage of supply, currently importing about 200 megawatts from Malaysia. And we think that SMR project will foster the utilization of nuclear energy for boosting economic competitiveness and added values from the mining products in the global market. We see that the existing electricity prices in Kalimantan already, well, the current prices in Indonesia indicate that our project will be economically viable to deploy that region. I think I answered your question.
Okay, thank you. Later on, maybe you can ask him again, Pak Rustam Haji.
Thank you. Thank you, too.
Thank you. Then I will invite Professor Zaki Suud. He's the professor in Bandung Institute of Technology, and he's also the expert head in the Indonesian Nuclear Society on the nuclear energy. Please, Pak Zaki Suud.
Thank you very much, Professor Charat. Good night, Mr. Artem. Thank you very much for your nice presentation. I think the KLT-40S is a very important history. They make very important history in nuclear development. By using KLT-40, which is floating, it can be they can give some special chance. For example, in Madura Island, several 20 years ago, there was some blackout accident, and then at that time, some of Indonesian officers actually they tried to find floating reactor to give that. Yeah, actually. So I think using floating reactor, it maybe can give some chance. For example, in case some accidental or some urgent necessity, then it can be a special chance for introduction of nuclear reactor. However, floating reactor maybe for common people, they maybe think that it will be not as safe as land-based, for example. But I think experts in KLT-40, they have think very deeply about this. What I would like to ask you, you mentioned that this reactor have some safety, passive safety feature and inherent safety feature. I think what is important concern of many people and many experts about nuclear reactor now, especially about LWR or PWR, is in some severe accident. For example, we can say some accident like Fukushima type accident, for example. Could you explain the future of the passive safety and inherent safety of this KLT-40? And maybe you can explain in case of accident like in Fukushima, what type of layer of defense they have against such type of accident? This is my first question. My second question, modular reactor is very important because it may cut the construction time. You mentioned that you can finish the construction in 3 years, but excuse me. Okay, but I expect if you have complete the module and then you just transport the module using the ship, I expect, is it possible if you can finish the construction overall in less than 2 years, for example? If it's possible, then I think it will improve very much the economical aspect. My third question, I see that your design is based on, many of your design is based on a couple of small reactor in each part. And then you can combine again in 2, 3 or larger module. We know that for small reactor, then the cost generally will be higher. my question, do you have some plan to make the larger module? For example, the module which is based on 100 megawatt electric or 200 megawatt electric. I guess in such module, it will be much economical. But maybe the concern is the possibility to move the design in a ship, a larger ship, for example, or maybe also aspect the safety. But in my case, for 100 megawatt electric, it's still good enough from the inherent safety or passive safety aspect. And I hope in such module, maybe if it combined in several 100 megawatt electric, for example, it can be quite competitive. We know that, for example, SCGR reactor or maybe SVBR reactor in Russia, they try to design the module 100 megawatt electric, and they found that the most optimal combination is 18 module they combine, and then they just use one large turbine. What's your opinion about this? Thank you.
Okay, Mr. Artem, please.
Okay, Mr. Zakisu, thank you for your question. And let me answer your last question about possible development of the SMR that will be around 100 megawatts or further capacity. So actually, we're now developing the family of RITM series SMR, including RITM 400 reactor. At first, it will be used at leader icebreaker, and it will be commissioned by 2027. And after that, we can look into possibility to implement this type of reactor for nuclear power plants, land-based or floating ones. Actually, we conducted market analysis and conducted negotiations with possible customers, our future customers, and so this analysis has shown that the reactor of 50 megawatt would be at first a suitable solution for all the market categories. So and we have facilities that can allow us to serially produce these SMRs, and you know that 6 SMRs are already manufactured, and 4 more are already contracted. So I think that we can reach the learning curve already in the nearest future and significantly reduce the cost of SMR. Speaking about the Fukushima accident, well,
oh, we lost the internet. Okay, Artem, are you there? We are still waiting, Mr. Artem Larionov. Something happened with him, with the internet.
Ya, biasanya internetnya bermasalah.
Ini memang masalah webinar memang begini, Pak. Kita tunggu sebentar.
Ya.
Artem, are you there? Oh, not yet. Pertanyaannya banyak sekali nih, menarik pertanyaan rekan-rekan semuanya ini. Keinginan tahuan terkait tsunami, pengaruh tsunami, bagaimana membawa ke Indonesia 100 sekian ton. Ini pertanyaan Pak Anwar Budianto. Kemudian ada, kalau mau Pak Indarta Aji, if Indonesia buy this reactor, how about the spent fuel treatment? That's good question. Will the spent fuel be taking back to Russia or not? Oke. Ini bisa ditanyakan nanti nih. Moga-moga Pak Artem bisa kita hubungi. Kemudian ada pertanyaan masalah regulasi. Moga-moga ini ada teman Bapeten. Apakah memang regulasi Indonesia sudah bisa mengakomodasi PLTN Terapung, bukan hanya PLTN yang berbasis di darat.
Mestinya bisa lah.
Kalau dulu, ini kan idenya juga dulu pernah ke kita pihak Rosatom, tapi pakai KLT 40 yang lama, itu yang enrichment-nya tinggi sekali uraniumnya. Waktu itu memang belum siap dari sisi regulasi juga, masih berbasis daratan. Belum juga, Pak Artem. Oke. Okay. Anna from Russia said that Artem will be back. He has some technical problem. Okay, we are waiting. Ini ada pertanyaan Pak Yaryanto, ini expert juga ini. Jadi sebenarnya nggak boleh nanya, udah bisa jawab sendiri. How many percent of enriched uranium used in your SMR design so that refueling cycle up to 6 years? It is very suitable for remote region.
Dia ini langsung dari Moskow apa dari Singapura?
Dari Moskow, Pak.
Oh, oke.
Dari Moskow. Tapi teman-teman yang di Singapura kayaknya juga ada ini di sini. Tapi Kalimantan Barat siap sekali nih ya Pak Rustamji ya.
Ya, sementara saya memandangnya perspektif gubernur seperti itu Pak Jarod. Karena di dalam RPJMD beliau sudah state untuk sebuah PLTN bagi hilirisasi industri di Kalimantan Barat. Kemudian beliau juga sudah merevisi rencana tata ruang wilayah Kalbar untuk memberikan arahan pada PLTN. Kemudian beliau juga sudah merevisi rencana induk pengembangan industri. Dan yang terakhir itu adalah RUET. Jadi beliau sudah meminta bauran energi itu di stage, bahwa salah satu bauran energi itu adalah menghadirkan energi yang bersumber dari PLTN. Karena menurut beliau saat ini memang betul, kita tadi Artem juga sudah menyampaikan, kita membeli dari Sesko Sarawak itu sebesar 200 megawatt. Namun demikian rasio elektrifikasi di Kalbar itu toh masih juga belum sampai 90%. Artinya kalaupun disebut surplus itu oleh karena infrastruktur jaringannya belum sepenuhnya masuk ke dalam grid. Jadi satu-satunya yang belum masuk ke dalam grid Kalimantan itu adalah Kalbar, dan diharapkan di akhir tahun 2020 ini atau 2021 itu grid Kalimantan maka sudah komplit. Nah, apabila surplus itu sudah bisa mengakses ke dalam grid Kalimantan, beliau meyakininya bahwa itu paling hanya untuk menerangi masyarakat ya, untuk mencapai 100%. Tetapi untuk mengembangkan industri, mau tidak mau kita memerlukan energi yang handal, murah, bersih, tidak intermittent, dan sebagainya. Dan dalam benak beliau sepertinya memang sudah harus dimulai lah. Itu kira-kira gambaran.
Terima kasih. Ini Pak Artem sudah masuk nih. Artem, could you please continue your explanation?
Меня почему-то не...
Okay.
Masih mute ya? Okay.
Sorry, dear colleagues, I had some problems with the phone. So let's continue. Actually, I'm not a technical specialist, and probably I wouldn't be able to give you the full answer for your technical question. However, you can send us your question in written form to our regional office, and we'll do our best to answer fully at your question concerning the technical issues about the Fukushima accident. I think I answered the other question about the size of the SMR.
Okay. Well, the last person I would like to invite is Pak Suryantoro. He's Deputy Chairman of Batan. Pak Suryantoro, are you there? Pak Sur?
Yes, I'm still on the front of my laptop. Thank you, Professor Jarod. Good night, everybody. Yes, thank you, Artem, for your very clear and very informative presentation. Your presentation is very useful for us regarding the floating nuclear power plant, and also not only floating, because you also explain about the land-based for the RITM technology. Okay, I would like to explain, that the Indonesia right now regarding the research and developments, we have a national research priority regarding the nuclear power plant. So right now we have the task to make the FS or feasibility study from the small modular reactors. That's not for the large, but it's for the SMR. Now you explain about the floating, and not only floating, it's about the SMR from Russia. That will be very useful for us, because we know that regarding our project of the FS, we will need the very close, very near technology that can be deployed. This is like you explain about because we will not, in this proposal will not the floating, but in the RITM will be maybe will be the one of the candidates that we have to study about that kind of the technology, because not only from the Russia, there is so many SMR in the world that can be implemented closer. So what I want to know is about the specification, about the price on the cost of this SMR, not floating. This is the land-based, because in the West Kalimantan, we will, and also regarding our regulation in Indonesia, the land-based will be is ready. But from the floating, maybe the regulatory body still a discussion about the floating technology to be implemented in the regulation. So what I want to know is about the cost of the small modular reactor, not from the first of kind, because of the first of kind is, I think it's still expensive. From the end of kind, it can be cheaper and maybe can be afforded by Indonesia. That is what I want to know about the cost. It is very important. On the another technical, like about the spent nuclear fuel, on the fuel we can discuss later about it. Thank you very much, Artem. Thank you, Prof. Jarod.
Yeah, okay. Please, Artem.
Sorry. Thank you greatly, Mr. Deputy General from Batan, for your question. And first of all, I would like to say that our team from Rosatom overseas, we are in contact with Batan and Ministry of Energy and Mineral Resources concerning the pre-feasibility studies. And speaking about the costs, as I have already said, I think that pre-feasibility study will provide better understanding of project implementation aspects, including the schedule of the project, the cost of SMR, because you know that the particular costs, both land-based and floating, can be determined precisely only at the stage of feasibility study, and they may vary greatly depending on site parameters, regulatory requirements, business models that will be appropriate for both parties, and of course at this stage we can determine the social and economic effects that will the SMR project bring to the region. And of course, the results of the pre-feasibility study will contain full and complete list of recommendations of further actions. And of course, we as Rosatom are ready to support our partners in developing the nuclear project, and we support the Indonesia to make a well-balanced decision about this question. Thank you.
Okay, thank you very much. Then I will read the question from the audience using the chat. First, I will read the question from Mr. I think it's Dr. Anwar Budianto. He stated like this: Indonesia is a maritime country, has around 70,000 islands. The chance to using the floating nuclear power plant are great. Each island can use the floating power plant to meet the energy needs of the island. Suppose that Indonesia wants to build an FNPP. How to transport the 146 tons RPV from Russia to Indonesia? Is it a modular or assembled from form in Indonesia? This is the question: how to carry the 146 tons.
So speaking about the FNPP, it will be assembled and fully built, constructed in Russia, and after that it will be transported by sea to the site. So there is no need to bring the elements of the station one by one to the place, because it is already assembled and ready for the operation. And all the special procedures will be done in Russia, and after that it will be transported to the place of operation. And I would like to admit that the great experience that we gained with academic Lomonosov of NPP transportation will be definitely used for this operation.
Okay, thank you. And this is another question from Mr. Indarta Aji. If Indonesia buy this reactor, how about spent fuel management? Will the spent fuel be taken back to Russia or not? This is it's very short question.
The shipping of spent nuclear fuel from foreign reactors to Russian Federation is governed by the federal legislation of Russian Federation and by Russian federal government decrees. And our national policy on spent nuclear fuel and radioactive waste disposal is that it should be disposed of in the country where it is generated. So for the specific case of spent fuel being transferred for processing in another country, example Russian Federation, the residual waste is generally returned to the originating country for long-term management. So I think that it's our policy that the storage facility for spent nuclear fuel are a country's responsibility. So that's a position of our country.
Yeah, thank you. And this is another question from Mr. Yaryanto. Maybe you can communicate directly with him, but I will read it because he is expert also on the nuclear energy. His question is, how many % of enriched uranium used in your SMR design so that refueling cycle up to 6 years? This is a good question when we are talking about to use the SMR in a remote region.
So speaking about academic Lomonosov, low enriched uranium fuel is used and at KLT40S reactors, and the maximal fuel enrichment of the core is 15.7%. The enrichment level for Ritam 200 reactors is under 20%. Such enrichment level ensures long-time operation without refueling, and which is very important, meets international non-proliferation requirements. So the fuel cycle of academic Lomonosov is 3 years. And speaking about Ritam series, we managed to increase it to 6 years for land-based SMR and up to 10 years for the floating energy solution.
Okay, well, this is very general question from Mr. Hisomi Aryadi. Is it possible to build the FNPP, this floating power plant in Indonesia? Because the Indonesia and Russia have different climate in terms of weather, air temperature, and other parameters. This is a very general question. Maybe the audience want to know also about this floating power plant.
Well, we in Rosatom offer to our potential customers great opportunities in terms of cooperation. We can look into opportunity of constructing the vessel itself on a foreign shipyard. However, the final assembly is being carried out in Russia because the nuclear island is being installed there, and we should be. I think it's very important. It is the final decision that the final assembly is made in Russia. However, we can offer our partners to for industrial cooperation, for example, turbine island, some INC equipment, and the vessel.
Okay, and this is from.
And I would like to add more.
Yeah.
That the design of the optimized FNPP considers the temperature parameters that are at Indonesia. So high temperature parameter is no problem for our design.
Okay, thank you. This is the question from Pak Sigit Asmara Santa. Oh, this is the person from Batam, and he already had been in the Ministry of Research and Technology also. What kind of schemes will Rosatom offer to the interest countries like Indonesia, for example? And how much, this is the electricity price, I think, cent per kilowatt hours do you promise? This is his question.
So am I right that you ask the person is asking about the business models? Yes, and the electricity price. Yes.
Yeah.
So actually, we are fully open for any business models. We offer flexible cooperation in terms of business models. It can be EPC or BO model. It can be some more like unique models. I'm speaking about leasing model. So I think that flexibility is one of the key competitive features of our floating energy solution. So we can negotiate with our potential customers any model that will be suitable for them and for both parties. Of course, well, from our point of view, BO model is most preferable, as this model eases the burden of the potential customer, and in terms of FNPP, the customer gets the electricity prices and all the difficulties concerning with the maintenance, construction, and other stuff. Rosatom takes on ourselves.
Okay, thank you. The last question, I think, from the chairman of Indonesian Nuclear Society, Pak Susilo Widodo, Dr. Susilo Widodo. You may ask directly, Pak Susilo, please. Pak Susilo, are you okay? Are you there? Oh, I had to unmute him.
Yeah, okay. Thank you, Pak Jarod, to unmute my system. Yeah, Atom, thank you very much for your presentation. Really very interesting for us and give us a clear picture about the floating nuclear power plant, especially and SMR as general. And this will give a big idea for us to make a further decision, hopefully, for our government about the first nuclear power plant should be operated in Indonesia. And could you please tell us the experience on the performance of the system during more than 8 month operation in Chukotka? Is there any trouble? Is there any blackout or if some seconds or minute of the system, or is this can operate well during 8 month operation? Thank you.
Thank you for your question, Mr. Society. Speaking about the stability of electricity supply in Chukotka, I can say that there have been no outages for the present, and you know that right now the FNPP is working along with the Bilibina nuclear power plant and Chonsk's coal-fired power station. So the whole energy system is well balanced, and in the future, Bilibina NPP will be decommissioned, and FNPP will fully replace it.
Okay. Well, thank you very much, Artem. But this is very interesting questions from one of the audience. Although I said Pak Susilo the last person to ask you. This is from Pak Petrus Gunarso. Mr. Petrus Gunarso asked this question: what country in the region, Southeast Asia, that closest in negotiation process with Rosatom to purchase or install your floating nuclear power plant? This is the curiosity of everyone, I think.
I think it's definitely Indonesia.
Okay. Anyway,
so
thank you very much.
Actually, I would like to finish our webinar that we in Rosatom are ready to hold joint meeting with all the ministers and agencies in the nuclear sphere to discuss further steps of bilateral cooperation on nuclear project development, and to make Indonesia become the first country in Asia to have a floating nuclear power plant.
Amen. Well, anyway, thank you very much, Artem, and the audience. We have a please short question. Yeah. Please.
Yes. Sorry. We know that Rosatom is very experienced in developing uranium-based nuclear power plant. My question is, why did Rosatom not develop thorium-based nuclear power plant? Because some people say that the cost of nuclear power plant can be reduced significantly by using thorium. I'm not a nuclear engineer. I'm an economist. Please explain.
Okay, this is a good question to make clear the thorium business in the world. Please, Artem, if you have any response or answer this question.
So actually, Rosatom has already developed a fuel solution for Ritom series reactor, which has been successfully tested for use on nuclear fuel, icebreakers of new generation. And as of now, the use of thorium as a fuel is, from our point of view and from the analysis we conducted internally, is economically unviable. However, Rosatom has technical competencies in thorium cycle development, and we actually are open for R&D collaboration to develop thorium fuel solution.
Okay, thank you.
Okay, thank you very much, Pak Kurtubi. Thank you, Artem. Thank you very much for
Thank you greatly.
everyone here. The audience here is more than 300 person. This is very surprising for us because in the evening session of webinar of Indonesian Nuclear Science Society, it's very rare. We have more than 300 person. It means that everyone, the Indonesian audience, they are very curious with the Rosatom technology, with the floating power plant, nuclear power plant technology. Hopefully, in the future, we invite again the Rosatom speakers. We would like to discuss many things about the Russian technology. I think they have many technology that they can share to us, to everybody in Indonesia. Thank you again, Rosatom, that we can make this kind of webinars. Thank you the panelists, Pak Kurtubi, Pak Rustamaji, Pak Zaki Suud, dan Pak Suryantoro, and all of you. And hope see you again. Next week we will have other interesting topics on this kind of webinars. Thank you again. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Thank you. Goodbye.
Many thanks, Acham. Bye. Many thanks, Prof. Jarod.
Ya. Terima kasih Pak Kurtubi, terima kasih Pak Rustamaji. Terima kasih Pak Suryantoro, Pak Jarod.
Ya, terima kasih semuanya.
Ya, meramaikan itu.
Semuanya, Pak Kurtubi.
Terima kasih Pak Jarod.
Sami-sami. Terima kasih. Minggu depan kita akan mengundang untuk SMR yang lain yang near term deployment juga. Mohon bisa mengikuti. Ini menarik juga. Jadi kita mengundang profesor dari Tsinghua University. Beliau akan cerita status dari high temperature reaktor yang akan dioperasikan tahun depan. Ini menarik, moga-moga memberikan nuansa pengetahuan bagi kita semua. Apa itu SMR? Nah, nanti berikutnya kita usahakan yang lain juga, termasuk yang mungkin masih proses desain atau mungkin yang masih dibicarakan di antara komunitas nuklir. Terima kasih sekali lagi untuk semuanya. Moga-moga tidak kapok.
Pak Jarod, terima kasih Prof. Jarod. Salim ini.
Terima kasih Prof. Jarod.
Oh, terima kasih. Sami-sami.
Salim ini salim.
Sami-sami. Nanti jangan kapok ikut lagi.
Pak Jarod itu dating apa? Pak Jarod datangkan narasumber dari Uni Emirat Arab.
Siap.
Oh, ya.
Nanti kami akan komunikasi juga. Ya.
Yang baru beroperasi itu.
Ya. Siap.
Yang dari Bangladesh juga bisa itu yang sedang bangun. Yang sedang bangun Bangladesh.
Wah, Bangladesh menarik
setuju.
juga.
Yang GDP-nya di bawah Indonesia tuh Prof. Jarod. Tapi sudah bangun.
Sip. Banyak sekali.
Sakwat. Saya nggak tahu punya kontaknya, lupa saya. Dulu pernah ketemu.
Saking banyak idenya sampai bingung ngatur jadwalnya.
Alhamdulillah.
Minggu depan kita juga mengundang Pak Lim Peng Hong untuk bercerita respons masyarakat Jepang setelah pasca Fukushima. Mungkin bisa bagus juga untuk mengetahui bagaimana
Hari ini hadir Pak Lim Peng Hong.
Oh, ada. Oh
ada,
ya, tadi
itu.
hadir ya. Ya.
Tulisannya Rim Peng Hong. Pakai katakana. Ada hadir itu.
Ya.
Perlu disapa itu. Pak Lim.
Lim, ada Pak Lim? Udah hilang?
Atau udah hilang?
Udah jam 11 malam
itu. Kalau Jepang udah agak malam itu.
Ya, apalagi malam Jumat. Kayaknya malam Jumat.
Ini
bagi
memang
saya.
Terima kasih.
Bagi saya yang menempatkan thorium atau uranium itu ya
direkam ya Pak ya.
Sama sekali bukan masalah utama karena harga komponen bahan bakar itu hanya di bawah 0,5 sen. Jadi mau thorium mau uranium sebenarnya pengaruhnya bukan masalah pilihan yang krusial. Ya. Karena komponen-komponen yang lain masih jauh lebih mahal untuk SMR gitu. Kecuali kalau bahan bakar itu harganya sudah menentukan baru kita milih apakah thorium, dan kalau kita sekarang Indonesia mestinya free saja, siapa yang bisa nyuplai plan yang sudah jadi dengan harga cocok, Nah, itulah yang harus dipilih.
Ya, saya kira kita tidak perlu mentertangkan antara thorium dan uranium, Pak.
Ya.
Karena HIMNI ini kan, Bhinneka Tunggal Ika kan.
Ya,
yang penting
betul.
goal dulu lah. Yang penting goal dulu.
Kita harus mampu merangkul semuanya.
Yang jelas bahan bakar itu presentasinya sangat rendah di harga. Komponen yang presentasinya rendah, di bawah setengah sen. Mau dihitung bolak-balik seperti apa, harga bahan bakar itu masih murah ketimbang biaya operasi dan ongkos konstruksi yang lain-lain gitu.
Ya. Tapi memang ini Pak, untuk mendatangkan beberapa speaker dari perusahaan besar itu memang butuh waktu. Biasanya memperkenalkan HIMNI itu memang harus terus-menerus kita lakukan. Karena banyak yang tidak tahu apa itu HIMNI.
Ya.
Apa sih itu?
Banyak yang salah dengan HIMNI.
Apalagi kalau dicari Google kan HIMNI beda lagi kan?
Iya. Kalau di Google masih kalah kenceng sama Himpunan Masyarakat Nias.
Nah,
nggak apa-apa.
Ini harus mengiklankan terus Pak Susilo itu supaya pendaftar banyak, supaya Pak Petrus itu susah ngitungnya itu sebagai bendahara.
Ada yang keliru, dipikir HIMNI itu HIPMI, Himpunan Pengusaha Muda Indonesia.
Oh, itu malah orang-orang kaya semua itu. Alhamdulillah kalau
HIMNI juga bisa ada yang jadi pengusaha.
Nanti Pak Jarod juga perlu mengundang ini Hitachi, mereka-mereka yang pengalaman konstruksi itu.
Ya. Makanya idenya terlalu banyak sampai bingung ngatur jadwalnya ini Pak Salim.
Berarti sampai Desember belum selesai ini ya Pak?
Enggak selesai. Ini. Karena banyak sekali SMR itu sepuluhan kan sebenarnya. Dari mulai yang sudah deployed masih detail desain sampai konseptual. Belum nanti kalau misalnya Torkon saya pengen juga loh gitu. Diberi waktu juga gitu.
Saya kira memang ya perlu juga itu diberi kesempatan Torkon Pak Jarod gitu.
Ya, ini kan semuanya kita rangkul kan supaya kita tidak terpecah-pecah gitulah. Kurang bagus kalau terpecah-pecah. Karena bagi pemerintah juga agak ragu-ragu kalau kita ceritanya sendiri-sendiri gitu. Ya, seolah-olah kita akhirnya membawa bendera sendiri.
Mungkin pas seminar ini Pak Susilo kesempatan mengenalkan HIMNI.
Oh ya, maksud saya selalu begitu, tapi kadang-kadang ya saya lihat situasi gitu.
Ya.
Kan kalau orangnya yang hadir banyak kesempatan.
Jadi pada saat peserta lagi turn on komputernya, jadi memang belum maksimal gitu. Nah, tapi beberapa kesempatan justru Pak Jarod yang membantu kami untuk memperkenalkan HIMNI, udah nggak masalah saya kira. Mudah-mudahan cukuplah apa yang selalu disampaikan Pak Jarod tentang HIMNI.
Mungkin ini Pak Susilo bisa bikin iklan pendek tentang HIMNI.
Betul.
Nah, nanti sebelum mulai ditayangkan dulu itu.
Video.
Suruh buatin Pak Yaryanto, suruh ngelukis itu. Lama nggak ngelukis itu.
Udah lama Pak. Aku dulu.
Biasanya beliau ngelukis pribadi sendiri itu, berdua sama istrinya. Ya saya kira terima kasih semuanya. Kita ketemu lagi minggu depan untuk topik yang lain. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih.
Waalaikumsalam warahmatullahi wabarakatuh.
Sampai ketemu lagi ya.